Alright, so in step 5, I need to start by building the circuit. And this is the section of the circuit that we're going to have to build for that step. I already labeled 5 kilo ohm rheostat and 330 ohm, let's see, that would be a drain resistor, and 2 10 microfarad caps. And then the LM337 is on this data sheet, the package. You have your output, input, and adjust. So I'm just going to rewrite that over here. This really doesn't tell you where they need to be hooked up. Anywho, so we don't need that. And let's get to work. First, making sure that's not plugged in, which it's not. And now we need a negative reference. So here's our ground, and then that's going to be our negative volts. So we're going to need a wire coming off there. Okay. Alright, so we're not going to need these. But we are going to need these. And something that's kind of going to be tricky to remember is this isn't negative. This is your ground. This is your negative. So you don't want to reverse the polarity of these capacitors because they will blow up. Let's just start with a clean slate here. Alright, so this is going to be our negative, and this is going to be, well, with respect to everything else in the circuit, this is technically going to be a positive voltage because this is a negative voltage. So our ground reference is going to be positive in this case. So let's bend the leads here so we're all on the same page. Alright. Now, first thing we need is a smoothing capacitor. And I'm just going to use a 10 microfarad. So, again, this negative needs to go over here on this positive lead because that's our negative. That's why I put it on these buses here, because this blue line is negative and this red line is positive, so it's going to be a little easier to not get confused, because the way I have it wired up here, it's correct. We have the black, the reference to ground, going to the positive, and then we have this red, the reference to negative voltage, going onto this negative bus. So that's correct. Now let's start wiring the sucker up. We have output voltage is going to be on this far pin, so I'm just going to bring this over here and bring it all the way over here to make it a little easier to see. Now the second pin, that's your input, the middle one. So that input is going to be on this negative bus right here. All right. And now we need to get a 330 ohm resistor, and that needs to go on between the output and the adjustment pin. So I need that. Well, I don't have 330, but I have a 220. And that is actually $216.5. All right. And this is going to be going from our output voltage, which is over here, and adjust, which is on the other side. So we're just going to stick that in there. Okay. Now we need a 5 kilo ohm rheostat. I have right here a 10 kilo ohm potentiometer, which I can just wire it to be a rheostat, and I probably should also wire it to be a 5 kilo ohm. So let's see. How. I think I have a 10 kilo ohm in here somewhere. Here's a 5 kilo ohm. I don't need this. Two, don't need that. One, don't need that. $10 kilo ohm. So in theory, if I put a 10 kilo ohm over with this 10 kilo ohm, it should turn it into a 5 kilo ohm. So let's test that theory. Okay. Now let's rewire this to be a rheostat and not a potentiometer. Okay, and now let's just see. Don't have any. Oh, thought I had one more. Let's just well, let's just probe it real quick and see all the way one way. What do we get? We get barely any ohms. That's expected. Let's crank it all the way to the other end. Now we should get around 5 if I did this correctly. And there we go. We got 4.937 kilo ohms, which is close enough to 5 kilo ohms. So we just converted this 10 kilo ohm potentiometer into a 5 kilo ohm rheostat. Now let me just draw what I did here. So this is a 10 kilo ohm, and all I did was add another resistor here. That was another 10 kilo ohm. So that essentially will turn this into a 5 kilo ohm rheostat. So now all I need to do is wire this rheostat going from one end of the between the linear voltage regulator and the resistor, and then have it come up to the ground reference. So one side is going to come over here to the adjustment bus, and then bring it over here, and then go over here to the ground and ground it. Now let me verify that. Ground is the center tapped. That's good. Now, what we're going to need is negative voltage, reference to ground to come over here. So now we have a nice place to measure our voltage, and that should give us a negative voltage. And we're going to need, this is a 4.7 microfarad. I want a 10 microfarad. So this will work. Now again, make sure that you don't mess up the polarity. So we have over here, this is our negative and this is our positive. So we're going to make sure that we don't mess that up. So yeah, let's plug it in and see if it works. All right, no immediate smoke, that's a good sign. Okay, let's see what we have. Should be negative voltage, and it is negative 13 volts. Let's crank it all the way to the other side. And what do we get? We get negative 1.2 volts. Let's go somewhere in the middle. And we've adjusted. So there you have it. We just built this third section over here. It would have been a lot easier if we had the PCB, but I don't have access to that. So this is what you get. Okay, so now that we have built this negative voltage regulator here, we can proceed to step 5. Now, let's see, what do we do first? Okay, so we need to see the range that this power supply can handle. Let's make sure this thing's plugged in. It is. Okay. So, red to red, black to black. Okay, so we have a range of negative 1.276 to negative 13. Guess it's charging up that cap. Let's wait for this to stabilize. Okay, let's just say 13.30 volts, and that's a negative. Now adjust it for negative 10 volts. Okay, so we got roughly negative 10. Well, I'm just going to stick with my negative 10.02 volts. That's good enough, I think. Now, let's wire in the load. So with this load over here, what are we going to get? Let me just take these off. All right, let's put the load on. Measure the voltage. Negative 8.63. And now current. Oh, well, good thing that there is a protection on there. Every once in a while, you do that, and could have been worse. It could have been in current, and I could have tried to measure volts, but it's fine. That actually didn't really do anything to the meter. It's the other way around that you can really mess up the meter. All right, so let's see. 19 milliamps. Okay, so now I need to see what the ripple is. See what I can do about that. So the ripple on the input side find a nice reference to ground. That'll work. Now the input is going to be over here. Okay. So the ripple is going to be roughly let's just say that's about 4 point something volts. Okay. Now let's see what the ripple is on the output. Alright, again, it's really hard to see. You can kind of see a waveform in there, and that's on the 5 millivolt scale, so let's say that's about 6 millivolts of a ripple. Alright, then that's it for the scope. Alright, now we're going to do the exact same thing, but with the, what was this, 1.6 or 1.7 kilo ohm resistor. Now let's measure current first, since we're already set up to do so. Five milliamps. Okay. Voltage. Well, I knew I was going to do it, so I did it. So that's about 9.72 volts. That's negative volts. Rest is calculation there. And now, again, we're going to do a nice short circuit test. And then right after, we're going to measure the voltage to see if it's protected or not, which it probably is. .09 volts. And again, that's negative. Is it protected? Yes. And then show off your new power supply. All right. I believe that's it. The rest is just filling out the next part, the report.